Science question 31. Consider a 1000 hertz sound wave in air at 10% relative humidity. At how many of the temperatures shown in figure 1, tells us where to go, does this symbol for this wave have a value of 18 and then some kind of amount here? Okay, so oftentimes in the ACT, they're going to give you an unfamiliar variable or something that's more unique because for some people, if they see something they don't know, they're like, oh, I can't figure this out. But in the ACT, especially the science, you can find the answers if you look. If you need them, more often than not, they're going to be here on the page. So I can find in passage 5, it talks about the attenuation coefficient is this symbol. And then also it gives us decimals per kilometer, and that's what that little symbol means, okay? So when I see those symbols, it doesn't faze me, and sometimes I'll switch it out with something else if I need to. I just know that I'll figure it out and find it on the page if I need to find it, okay? So this is really helpful. They have given us exactly where to look. Okay, it's told us to look in figure 1. So we have a figure 2 and a figure 1. So we're going to make sure we go to the right figure to find the answer. Okay, what other information have we been given? It's saying consider this 1000 hertz sound wave. Okay, let's take a minute and look at figure 1. Here on the bottom, we have temperature. Okay, and they want to know a little bit about temperature. There is a part where they're saying, hey, right there, how many of the temperatures shown? Like we're going to be referring to that. Okay, what else does it give us? Okay, we have this right here, which we learned is the decibels per kilometer, but isn't essential, right? And oh, there's that symbol. I found it on our question too. Okay, at some point we're going to be needing 18 there. Okay, but where's this hertz that we were looking at? Up here in the key, we can find the hertz and more specifically the 1000. Okay, and so for this one, what I'm going to do and what I like to do if, I have time, and you may not do this on the ACT, and that's fine, I'm going to focus on that solid line here. So starting here, it's going to remind myself that this is the line that I'm going to be paying attention to for this question. All right, now that we've looked at the graph, let's go back to the question. Okay, so starting here, consider a 1000 hertz sound wave, which we are considering, it's all in pink, in air at 10% relative humidity. At how many of the temperatures in green down there shown in figure 1 does this symbol, that coefficient for this wave, have a value of 18? Okay, so remember here's that 18. It's coming into play. So we're going to see how many times we're going to take this 18 all the way across, and how many times does this 18 line up with our temperature? How many of the temperatures does the hertz hit that? And so what I'm going to do is, well, I'll do the green again. Look, we can see it hits right here and here, here and here. And it's telling us that, hey, at this point it hits this temperature, this temperature, this temperature, and also this temperature. And so they want to know how many times does it hit the temperature? The answer is going to be 4. 4 different times. Does that make sense? So just kind of another wrap up, because there are a lot of moving parts here. We considered the 1000 hertz sound wave, and we drew that out in pink, right? And we figured out how many of these green temperatures, how many times this 1000 hertz sound wave crossed the temperature at 18 of the decibels per kilometer. And we figured out it was 4 different times.